Alright, this is on the, my title's different, but you guys took a earn your grade on 5, 1 all the way up to 5, I think 5.2, 5.4, 5.2. 1 point apiece, you're supposed to match these. You should recognize you have a negative here, so that's called the negative angle identity for cosine. Basically means that the formula is cosine of negative theta equals just cosine of theta. So there you're just looking for a cosine of 75, which is choice F. Number 2 says negative sine 35 degrees. This is also the negative angle identity. Negative sine of theta equals sine of negative theta. So that would be choice A. Number 3 says cosine of x. So I have to figure one that looks like cosine of x. If I look at this one, I can actually simplify it. Cotangent is cosine over sine. And then sine of x is just sine over 1. My sines will cancel there. So this expression C is equal to cosine. Tangent squared x, if I look at any of these, this one looks like the Pythagorean identity. Tangent squared x plus 1 equals secant squared x. If I subtract 1, I get tangent squared x equals negative 1 plus secant squared x, and that's what I wanted, so that's choice B. And then E there. This could look like the one we just learned, the double angle identity, but if you just change sine of 15, cosecant of 15 degrees is really 1 over sine of 15, and you cancel these out, you're just left with 1. That would be choice E. And this, make sure you recognize that I'm giving you more choices that are necessary, so D was not used. D minus. Use the fundamental trig identities. So fundamental just means the Pythagorean, quotient, and reciprocal identities. To write in terms of sine and cosines and then simplify. Secant squared alpha is 1 over cosine squared alpha by the reciprocal identity. Tangent squared alpha is sine squared alpha over cosine squared alpha. Here you have a common denominator, so I have 1 minus sine squared alpha over cosine alpha squared alpha. I'm going to use the Pythagorean identity here. Cosine squared plus sine squared equals 1. If I subtract sine squared from both sides, I have cosine squared equals 1 minus sine squared. So instead of writing 1 minus sine squared alpha, I'm going to write cosine squared alpha, and the same expression over itself will equal 1. The next one, is it D plus on yours? Yeah. Simplify cotangent squared alpha plus secant alpha times cosine of alpha. The first thing you want to do is try to change things to sine and cosines. Now some of you guys try to change that one into sine, cosine squared over sine squared. If you just transform the right side, secant is 1 over cosine by the reciprocal identity, multiply across. When you cancel these, you get 1. So this whole expression over here on the right side equals 1. So cotangent squared alpha plus 1, what is that? That's a Pythagorean identity. This is all equal to cosecant squared alpha. Next one, C or C minus? C. Alright, a lot of students did this problem wrong, and I'll read it out loud. Given tangent of x equals negative 5/4, where x is in quadrant 2, use the trig identities. What does that mean? No letters x, y, and r, and no triangles. Okay? So if you have something on your paper, like you draw a triangle and you're using the Pythagorean theorem to find the letters x, y, and r, that would be inappropriate at this time. It's kind of like if I tell my son, throw the ball to first base, and he just throws it to third, that's wrong, right? He's throwing it, but he's throwing it to the wrong place. They want us to find secant. You should be thinking about the relationship between tangent and secant, and that is the Pythagorean identity. Tangent squared x plus 1 equals secant squared x. Remember, a student-friendly way of writing this is tangent of x squared plus 1 equals secant of x squared. Tangent of x is negative 5/4. I'm going to substitute that in here. Negative 5/4 times negative 5/4 gives you 25 over 16. 1 becomes 16 over 16 because you need a common denominator. This becomes 41 over 6. If you take the square root of both sides, remember when you take the square root of an equation, you have both plus or minus. The square root of 41 is a prime number, which means you can't break it down into factors. Square root of 16 is 4. Your choices are plus or minus radical 41 over 4 equals secant of x. Remember, you're in quadrant 2. All students take calculus. Only sine and cosecant are positive. Everything else is negative. Secant of x equals negative radical 41 over 4. We're on a roll. Let's just go on the backside. The next question. On yours, is it C+? Yes. Simplify using cosine and sine. Tangent squared alpha, cosine squared alpha, plus cotangent squared alpha, sine squared alpha. What is that equal to? Well, it doesn't tell you to solve, it just tells you to simplify. Remember, there's multiplication here and here, so tangent squared alpha tells you use sine and cosine. So I transform that using the quotient identity, put it over 1 here. Cotangent squared alpha is cosine squared alpha over sine squared alpha, and sine squared alpha as a fraction is just over 1. Here I'm canceling my sines on this side, so you're just left with cosine squared alpha. Over here I'm canceling my cosine, so I have sine squared alpha plus cosine squared alpha, which is the Pythagorean identity, which equals 1. Alright, let's get into a little more difficult problems. Number 10. Verify cosine of x minus secant of x equals negative sine x times tangent of x. I'm going to show you two solutions. I'm going to show you the right-hand side first. Let's make it a little bit better. Negative sine of x is there in the numerator, right, over 1. And tangent is sine over cosine. Negative sine times sine gives me negative sine squared x. That looks like the form of the Pythagorean identity, and it is. Notice over here I did it incorrectly, I think, first. I subtracted cosine squared first, and I got 1 minus cosine squared equals positive sine squared. And I wanted negative sine squared, so I just multiplied both sides by negative 1. Negative sine squared is equal to, that becomes a negative, and this one becomes a positive. Negative sine squared equals cosine squared minus 1. There's a substitution. I see negative sine squared x. Now I can write cosine squared minus 1. Notice you already have a common denominator of a cosine. And why would I want to separate at this time? Because if you look on this side, there are two expressions separated by subtraction. So I wrote cosine squared over cosine x and negative 1 over cosine x. Here you're canceling one cosine, so you get cosine x, and then 1 over cosine is secant. So there I transformed, working only on the right-hand side. If you did the left-hand side, it's basically the reverse of what we just did. If I work only on the left-hand side, I have cosine x minus secant of x. I have, make that a fraction, cosine x over 1 minus 1 over cosine by the reciprocal identity. In order to subtract these fractions, these have to be the same, lowest common denominator. The common denominator is cosine. This side is missing it, so I'm going to multiply by cosine over cosine. So I get cosine squared x times cosine, and this side is just stays the same. Now you have a common denominator, you can put those together, cosine squared x minus 1 over cosine of x. Cosine squared x minus 1 is the Pythagorean identity, which we did above, or what did I do? I subtracted sine squared and then subtracted 1. And then instead of writing cosine squared x minus 1, we can just write negative cosine squared x. Sine squared x, there are two signs, but pay attention, both of the signs are not negative. Negative sine times sine. I put that one over cosine. Sine over cosine by the quotient identity is tangent, and this side stays the same. Therefore, working only on the left-hand side gives you what you see on the right-hand side. I think the most difficult question? I wonder if I'm going to put this on the test on Monday. Hint, hint. Number 11 says to simplify, you have sine x over 1 minus cosine x plus 1 minus cosine x over sine of x. The common mistake for students was we did an example in class where it was equals, and then we multiplied by the conjugate. Here you're not doing that because you don't have an equal sign. Here you are adding fractions. To add fractions, you need a common denominator. This side has 1 minus cosine x. This one does not have 1 minus cosine x. So I just said multiply by 1 minus cosine over 1 minus cosine, because that's equal to 1. This side has a sine x, and this one does not in the denominator. So I'm going to multiply by sine over sine. That gives you sine squared x. And here I'm not going to distribute. Over here, a lot of students made a common mistake to think this was 1 minus cosine squared x. That's incorrect. You're basically using a box method or FOIL there. 1 minus cosine, 1 minus cosine. So if you multiply, you get 1 negative 2 cosine and cosine squared x. Now, I highlighted this one in pink. And why did I do that? Because now that you have a common denominator, I can add all of this in the numerator. And that's my work right here. Zoom in a little bit. So now I have cosine squared x plus sine squared x plus 1 minus 2 cosine x. Cosine squared x plus sine squared x is a Pythagorean identity. That turns into 1. I added these ones, so that becomes 2. Where did I go from there? So you have 2 minus 2 cosine x. And then from there, I just took out a greatest common factor, which was a 2. So you have 2 times the quantity 1 minus cosine x over sine x over 1 minus cosine x. The 1 minus cosine x is canceled, and you're left with 2 over sine x. So if you wrote 2 over sine x, or 2 times cosecant of x, that would have been the correct answer. So that problem is a rational expressions with trigonometry. That's why a lot of work, a lot of algebra. And the last question. Solve in the interval between 0 and 360. Use the algebraic method. 2 sine squared x minus 3 sine x equals negative 1. To solve quadratics, you're going to have to set that equal to 0. So I'm going to add 1 to both sides. This equals 0. And you have 2 sine squared x minus 3 sine x plus 1. Remember, if you get intimidated by this, just take out the sign, and you basically have something that looks like this. 2x squared minus 3x plus 1. I'm going to try to factor this. A times c is 2. My b value is negative 3. The two numbers that multiply to be positive 2 are negative 2 times negative 1. And these two numbers here will add to be negative 3. These two terms are basically breaking up the middle term. Then you put in the first term in the top left and the last term in the bottom right, and then you take out your greatest common factor. Here you have an x in common. Here you have a 2x. Here you have a negative 1. Here you have a negative 1. And remember, you can always multiply to check your answer. I'm left with x minus 1 and 2x minus 1. Remember, you took out the sign, so essentially what you have is 2 sine x minus 1 times sine of x minus 1 equals 0. You apply the zero product rule. set each of those equal to 0. Add 1 divided by 2, sine of x equals 1/2. If you take the inverse, where is sine positive 1/2? Your choices are 30 and 150. And here you get add 1 and you get sine of x equals 1. Sine is 1 only at 90 degrees. So you have three solutions, 30, 150, and 90 degrees. What's missing on this earn your grade that will be on your test on Monday, you can write it down, is the 5.4, which is double angle identities, and the sum and difference identities. Okay? So those are some things that are missing from this earn your grade.